All right, so I'm picking up right where I left off. We were plugging 2 into the function. We're trying to find a here. So you choose a point. We plug 2 into the function. We want to get 1452 as our answer. And then we solve for a. So 11 squared is going to give you 121. We have 121 times a equals 1452. To get a by itself, we divide both sides by 121. And we end up with a as our final answer here. So that means a is going to be 12. We have our common ratio, which is our base, which is 11. And then we will write our final answer. Let's see, do I have it here? Here it is. So the final answer is going to be f of x equals 12 times 11 raised to the x power. So that is what you will put for problems like number 18. Number 19, we have another scenario. We're going to say, okay, is it linear? Is it exponential? Is it neither of them? This case, it looks more like it's going to be a linear situation. You see it's going from 1 to 7. That's a change of 6. From 13 to 19 is another change of 6. Again, if you just subtract them going backwards, 25 minus 19 is 6. 19 minus 13 is 6. 13 minus 7 is 6. We conclude that our rate of change is 6. So now we have the slope. Now we need to write it in slope-intercept form. So one way you can do it, if you didn't have the table, you can go through, okay, y equals mx plus b is going to be our equation. Again, you pick a point to plug into the function to solve for the other value. If you plug in 0 for x, you plug in 7 for y, you will get b equals 7. And I chose 0 and 7 because that's an easy enough point to work with, but you could have chosen any 2 points in this table to solve for b. You would have gotten the same answer as long as you do everything correctly. So that is the end of this section of the video. Now I'm going to switch over to Math Excel to look at the problem starting with number 20. So hang on. All right, so this is the first of your graph matching problems that you have in the problem set. So I'll go through this one kind of slow, but I may be picking it up as we go through the rest of the problems. So it says match the graph that's given here to one of the following functions. So we would start off just trying to look at each of the different functions. We observe some of the qualities in our graph and we see what fits. So now we know that our original exponential function is supposed to simply go from the left to the right. It should be an increasing function. We know that it's supposed to cross at 0 and 1, and it should have another point at 1 comma whatever the base is. You see that we obviously don't have that type of situation, so we know that it's some kind of transformation that's going on here. The first thing that we notice is that it is no longer increasing from left to right, but it is decreasing from left to right. So that means that it is a function that's been flipped across the y-axis. Now going back to our unit on transformations, if it's flipped across the y-axis, then we know we should be looking at a function that has an x that is negative. So we can already eliminate choice A, choice C, we can eliminate choice E, we can eliminate choice F, we can eliminate choice H. So we've already narrowed it down to one of 3 different options. So we're looking for a function that has a negative x just based off of it flipping across the y-axis. So it's either B, D, or G. So now we have to look at those. Okay, B is only reflected across the y-axis and it doesn't have any shift up or down. So even though our base is 5, by looking at B, we would still expect to get that original point that crosses at 0, 1 because it's not moved up or down or left or right. So this graph would not be answer choice B. We look at answer choice D. D also doesn't move left or right or up or down. D actually has a negative on the entire function, which, if you can recall, is going to indicate a reflection across the x-axis. So with answer choice D, because everything is negative, we would expect our function to also be below the x-axis. It will be reflected down. So it is not answer choice D. G is our only remaining option, but let's see if that actually matches. So G is actually a transformation to the left 1 unit because we have this positive 1 here that is directly with the x. So would this function be transformed to the left? And we see ours is on the right side, so we're like, hey, maybe something weird is going on here. But remember, the graph was reflected over the y-axis. So that transformation that would have been over here to the left one has now been flipped over here to the right one. So that means that, okay, we have this point here that we're expecting to see. This is most likely our best bet. If you still want to double check just for your certainty, go ahead and say, okay, if I plug in 0 for x, I should get 5 for y, because this graph also has a point at 0, 5. If you plug in 0 for g, you get 5 raised to the 1 minus 0, which will be 5 raised to the first power. So it is indeed answer choice G, which you can see, and we are now moving on. Number 21. Okay, I actually went ahead and I opened up Desmos for this one because I think it may be a little bit confusing. So I went through it, but I said let me go back and actually show you these illustrations so it doesn't get any more confusing. So once again, we see that all of our bases here are 7. So I'm just going to start off with the parent graph, 7 raised to, oops, what happened here? Let's see. Let's try again, 7 raised to the x power. So you see that you have a simple exponential function is increasing from the left to the right. So we notice that this one has been reflected across the x-axis. So we know that we're looking for some type of negative in front of the entire function. So that reflects it down across the x-axis. But notice that, okay, if you reflect the regular exponential function down, you still don't quite have this picture. So you see what it looks like when it's reflected down, but we see that, hey, guess what? This one is also reflected across the y-axis as well. So that means that it would have a negative on the x because, okay, after it's flipped down over the x-axis, it's also going to be flipped over across the y-axis, meaning that the x in the function will also be negative. So now, we see that we have this shape, and then again you can just check for 1 or 2 points on the graph if you want to, just by looking at this without even looking at the one that's graphed over here. Remember that that original point on the function with no transformations at all should be right here at 0, 1. So if our function is reflected across the x-axis, that brought it down to 0 and -1, and if it's reflected across the y-axis, well, the point isn't going to move because it's on the y-axis. So we still have this point that's resting here at 0 and -1. So that tells us that, okay, we have our reflections, but no further transformation. And so we can stop and be satisfied here with -7 raised to the negative x power. So that is how we know that the answer choice for this graph is going to be D. Our next graph. So let's see what we have going on here this time. So this one looks like a regular parent function. You see it has it's increasing from left to right. It has the point 0, 1. The next point on the graph over will tell us what our base is. That base is going to be at, let's see, 1, 2, 3, 4, 5 here. So our base should be 5. Obviously, all of the answer choices are 5, but sometimes they may ask us to type it in. So that is how you go through it. You say, okay, it's at 0 and 1. There's no transformations left or right. It's going up from left to right. There's no transformations up or down. You see it has a point at 1 and 5. So that means that our base in this case is 5. So it is A. It is our original exponential function with a base of 5 and no other transformations. Number 23. Matching the graph again. Okay, so we see the point that would have been at 0 and 1 has been moved down 1. And we know for sure because, again, the horizontal asymptote, which is usually at 0, is now down at -1. So the point that's usually at 0, 1 for our exponential functions is now at 0, 0. So it's a graph that's been moved down 1 point. So we will be looking for an exponential function over here that has a vertical shift that is going down 1. So just going through them, this has no vertical shift, B has no vertical shift, C has no vertical shift, D doesn't, E does have a vertical shift, but let's just make sure we don't have any others with vertical shifts. H has a vertical shift, but it is going up 1. So then that leaves us with E as our answer choice. It is the only one that has a vertical shift of going down 1 unit, which complies with our graph that goes down 1 unit. Also, if you want to check another point, you can say, okay, when I plug in 1, I expect to get 3 as my next point. If you plug 1 into E, 4 to the first power is 4 minus 1 is indeed 3. Number 24, it looks like I will be doing this one, so hang on 1 second. Okay, so now I have a fresh problem for number 24, so I'll take you guys through how to do this one. Let me make it a little bit smaller so it fits. Okay, so now we have, it says use transformations to graph the function, determine the domain, range, and the horizontal asymptote. So when you're graphing it, you want to grab the exponential function tool, so you click it, you put it on the graph, it gives you the basic exponential function, and notice that it says that our base is E. That is what it's automatically going to be when you graph the exponential functions, when you pull it up, but you want to make sure that you change it to whatever your base is in the problem. So we'll change our base here to 4, and we see this plus 3 that's on the outside of the function, which indicates a vertical shift of 3 units, and it has no further transformations, so we can stop there and we're going to save it. I'm clicking save and then check answer, and we got the graphing part out of the way. So now what's the domain? Your exponential functions domain is always going to be all real numbers. You can plug anything into that exponent up there, any number, any real number into that exponent up there, and you're always going to get a solution. So our domain is going to be going from negative infinity to positive infinity, and our range now is going to be, okay, it doesn't go from 0, it actually starts here at 3, which is our horizontal asymptote. So it goes from 3 up to positive infinity. So we're going to start at 3 with the parentheses because it never quite crosses 3 to positive infinity. And now what line is the horizontal asymptote? It is the line y equals 3. This graph never crosses the line y equals 3. So and then also it says type an equation, not just a number. So we're typing y equals 3 literally. And I think we have time for one more. This is number 25 now. Using transformations again. This one was very similar to the last one. We're going to grab our exponential function tool, open it up. Remember to change your base to match the base of your problem. In our case, it is 5 over here. And the vertical shift this time is going down 3 units. So everything moves down 3. Let's save it. Submit our answer. We get it correct. Now, what is the domain? Once again, our domain goes from left to right, from negative infinity, and it keeps going in the positive direction to positive infinity. So we're going from negative infinity to positive infinity. And we're going to check our answer. Fantastic. And then finally, what is the range? The range this time it moved down 3, so it's going from negative 3 to positive infinity. And our horizontal asymptote is going to be y equals -3.